Okay, let's see what we got today. Hard. Count number of trapezoids part 2. You're given a 2D integer array of points, or points of I is a xy coordinate, representing coordinates in the either point in the Cartesian plane. Return the number of unique trapezoids. So unique, so not so yesterday was horizontal, but here is just any. That can be formed by choosing any 4 distinct points from points. Trapezoid is a convex quadrilateral with at least one pair of parallel sides. 2 lines parallel and only if they have the same slope. Okay. Interesting. So yes, what's the difference between yesterday and today? Yesterday was the trapezoid formed by horizontal parallel lines. Here's, let's see, it can even be horizontal or vertical parallel lines or diagonal parallel lines. So we have to think about slopes. How do I want to deal with slopes? Maybe reduced fractions. I don't really think about this. Trying to determine if two decimals will always be equivalent. I guess I can convert them to decimal slopes and compare those, even if they're kind of weird decimals non-repeating. Or I guess all slopes would be repeating if they're going to be formed from integer coordinates. Okay, so we're dealing with slopes. So it's also slopes and maybe the y coordinate of the slope to differentiate from collinear sides. So for every pair of points, determine the slope of those points. Determine the y coordinate of the line drawn. So like for every pair of points, like think of the line drawn between those. Find the slope of the line and the y coordinate of the line. And then have a dictionary so that you know for every slope what the y coordinates are of the lines that had that slope, and also the count of the points. Counts of the points would be hard to determine immediately, but maybe you could. Every slope and y coordinate, the number of things. Oh boy. Also, that doesn't seem very fast. Also have to deal with vertical slopes. So it is pretty restrictive, only 500 points compared to, I think it was like in the tens of thousands last time. 10 to the 5th, I think it was. And also kind of restrictive in the coordinates. I wonder if there's a better way of thinking about this. What is the better way of thinking about this? Maybe think about it in terms of vectors. I don't know about that. Yeah, about in terms of vectors. Really don't want to calculate y coordinates of all these things. It's a little too much math. Like maybe that's just required. So what I'm thinking about is like for every pair of points, calculate, consider the line connecting them. And here, find a slope of the line, the y coordinate of line, or I guess this is the y-intercept of line. And then have some sort of dictionary. So that for every slope and y-intercept, it maps to some count. The count of the number of things with that slope and y-intercept, which is equal to count is same as the number of sides formed on that line. And then maybe I have two dictionaries, one for slope to y-intercept, another one for slope to y-intercept to count slope to a list of y-intercepts, and slope y-intercept to a count. Or maybe have a dictionary with a dictionary inside it. Is that even possible? So I need to let's say I have slope 1. Let's say slope is 1/2. And let's say I have points that have y-intercept of 3 and 5, and for the y-intercept of 3, there's like there's maybe 2 kind of pairs of points. No, that's not possible. There's 3 pairs of points. 3 sides with that, and the y-intercept of 5, there's like maybe 1 side of that. So 2 points on that y-intercept and slope would make 1 side. 3 points on that line would make 3. Yeah. So let's say it's 2 sides. And so then you do something where like any of these 3 sides could work with this side to form a trapezoid. Oh boy. thinking about it, it's possible that it's going to double count, because you'd have to check to see if it's not like a square or rectangle. Because if it's a square or rectangle, then technically both the pairs of opposite sides would do the same logic and come out to saying that they form a trapezoid. You don't want to double count that. Need to not double count rectangles. Is rectangles concerned here? Or is it like a rhombus? I guess rhombus. Yeah, rhombus. A rectangle is a rhombus. Right? Rhombus. Yeah, having no right angles as contrast with a square. Oh wait. It has, by definition, no right angles. Rhombus is equilateral quadrilateral. Yeah. Rectangles, rhombuses. Or say, or maybe I'm thinking of a parallelogram. What the hell? Square is a rectangle, square is a rhombus. Oh. Opposite sides would be the same length? No. What's the difference between a parallelogram and a rhombus? Parallelogram versus rhombus. Yeah, no geometry. Rhombus, all four sides are equal in length. I thought that was a kite. Okay, yeah. I guess rhombuses are kites. Parallelograms are not. Rhombuses have the same side length on every side. Where the angles are definitely not square. Squares should be rhombuses, right? Yeah, I see. Rectangles don't need to have the same side lengths on the opposite sides. Or rectangles do need to have the same side lengths on the opposite sides. They don't need to, or yeah, okay. Square has square angles as its corners. They also have parallel lines, and they have same side lengths. Opposite sides, same side lengths. Okay, rhombus just doesn't have the. What the? This is just a poor drawing. This should be a fucking kite. Ugh. Okay, yeah, this is the drawing for rhombus. That was just. Ooh. Oh my god, I just hate. Who did this? Who did this? This is a disgusting. That's just a disgustingly bad diagram. Like, this is just not explaining a rhombus correctly. This is a parallelogram. Almost needs to have the same side lengths. Oh, Jesus Christ. Unless maybe some sort of process where they made it into this figure that kind of reshaped the dimensions of the image where originally the image was correctly sized. Anyways, okay. Need to not double parallel parts. Okay. Is there a way to... Am I just gonna have to... Am I just going to have to register it? Alright, let's go ahead and do some math here. 500, choose 4 is the maximum number of things here. Okay. Okay. That's what, 25 billion? That's 2.5 billion. So that's too many to have some sort of set. Like I was thinking maybe storing the indices of the points and then having a 4-value tuple to identify whether or not I've registered a particular quadrilateral as a trapezoid, and then incrementing the count if that's the unique addition to the set. But that's going to be too many points, so that's going to be too many possible tuples in the set. How to do this quickly, efficiently, and not over counting. I guess you could do something funky. Like if you... What could you do? If you saw that something is a trapezoid, then maybe modify. If you saw something's a trapezoid, and you saw that the other pairs of sides was parallel, then you only count it if that slope hasn't already been used. I also need to consider vertical slopes. That has possibly and likely no y-intercept. Or I guess if it's the y-axis, then like the line is the y-intercept. You consider really close or using x-intercept in lieu of the y-intercept. There's a... I wonder if there's a neat way of doing, if there's a trick to doing this. Slopes, slope, 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 slope. There's a vector. So for every slope, so I go to that points list. I think I have to consider every point with every other point and register its slope. If I can register the slope as a reduced fraction, I don't know if that makes any sense. So when I register the slope of 2 points, if that registry is the first one, and what then I need to figure out the y-intercept of that line from those points, or the x-intercept if the slope is undefined, vertical, if the line's vertical. And then the next time I do a pair of points, if it matches that previous slope and it also matches the previous intercept, then I need to add to some counter. If it doesn't match this, if it matches slope and it has a different intercept, then I create a new counter. And when I do the pairing of, oh my god, when I do the pairing of the slopes with every other slope, I do the pairing of things the same slope with 2 different intercepts, then for each of those pairings I actually do need to check to see if it's not a parallel pairing. That's disgust. I don't even know how I would do that. Like I would need to keep track of the points that were involved in the creation of those slopes, intercepts. Because only then I would be able to backtrack to figure out whether or not they're also forming another set of parallel sides in the other way. Only one trapezoid can be formed. I love how the examples of these are just like the most straightforward examples you've ever seen in your life. I guess this one's alright, to be honest. But the example 2, or the last example, is always just some trivial shit. I guess this one's nice in that they at least gave you some vertical slopes to consider. Man, I don't even know. What topic is this? Some sort of graphics shit? I wonder. Is this some sort of graphics shit? wonder if there's some trapezoid or quadrilateral property that I'm not getting that makes this simpler to analyze. So if I go from each point, can I order the other points in some way to make it? I go from each point and consider that a point on the trapezoid formed with that point. So from this point, consider all the consider creating a list of other points and the slopes to those other points. That makes sense. What if I can do a graph? The number of paths within a fully connected graph of points where the paths have like alternating equal values. Fully connected graph of points. I guess points are nodes here. And edges are the slopes between nodes. And how many paths have alternating? No, it's not even alternating, right? It's just has some alternation of equivalent, have some pattern of A, B, A, C values in its edges, or A, B, B, I guess. Because then the alternating, the opposing sides that have the same slope is equivalent to the edges that are the same slope. And so they have the same values. I wonder if this formulation is any good. I don't even recall having to deal with anything like this. Fully connected graphs is like cyclic. It's definitely cyclic. Any trapezoid is going to be, or any quadrilateral is going to be cyclic. Jesus. Most of the graphs that I deal with are going to be non-cyclic, I say. Graphs based on previous kind of problems. B, A, B. So let's say I have, this is A, well, these are the, let's say this is point capital A, and this side is lowercase a. So from this point, I go here, and then how would I mimic that in the code? So from A, I do a search of its neighbors, and for every neighbor I put it in the stack or the queue. When I do the neighbor, how am I doing? A, B, A, B. When I do the neighbor node, I look at that node's neighbor and put those things in the queue. This is going to go through every single possible path. That's just not for it. It's going to be 2.5 billion possible kind of four-lane sequences. There has to be some mode. It's just more efficient than this. From a node, from a point, I go to let's go back to fundamentals here. For every pair, for every point, go to every other point, registered state. Okay, let's go ahead and start doing that. I guess I probably want to do indices here. So n is the length of points for every index in range. So I'll use p index. I guess this might be pin 1. Right, well, I guess I could just do p1. And then for p2 in range, and p1 plus 1 to n. I guess I can also say p1 is x1, x2. So let me think. x1, x2. Yeah, whatever. And let's say I have, let's say I have lines as an array, and this is going to be tuples that are slopes and intercept, which by default is y-intercept, unless it's a vertical line, in which case it'll be the x-intercept. So then I'll say here, slope is going to be, I guess I can do the edge case first. So if we're dealing with a vertical line, then the x coordinate should be the same, and the y coordinate should be different. So if P1, the x-coordinate, is equal to P2's coordinate, this is a vertical, then I'll say I need to find the y-intercept, or find the x-intercept. Well, the x-intercept is x-coordinate, right? So, yeah, so it's going to be lines that append infinite and then x-coordinate. Well, can't put else. The slope is calculated, so this can be the difference in the y-coordinates divided by the difference in the x-coordinates. So P21 minus P1, 1, change in y divided by change in x. P2, 0 minus P1, 0. And then lines, and then you find the fucking look. Ugh, find the y coordinate. Find the y coordinate. Y coordinate of this. So it should be something it's just a little bit of math, right? Use the slope intercept. Itself b is equal to y minus mx, where y and x are either p1 or p2's coordinates. So let's say this is the y-intercept is equal to let's use the first point. So y minus slope times b slope times x, so it would be p1. Oops, this is y coordinate. Y minus mx. Where y equals mx plus b. And then lines append slope y-intercept. So just print this out. And to make this easier on myself, I'm going to go ahead and sort the points. I'm not sure if this is going to make it easier. Maybe. Okay, let's see if this works okay-ish. Not scriptable. Oh, those are indices, that's right. Yeah, I guess I do need to just convert these. P1 is the index. Or I just put points at P1. Points at P2. Oh, this is disgusting. No, yeah, this is just too messy. Sometimes you just gotta give in and create variables. Let's say x1, y1 is points at P1. x2, y2 is points at P2. I guess this just makes it a lot more readable. x1 equals x2, vertical. Use the x-intercept. this earlier. This is my one. Right, so from here to here, the slope is -1. I guess I should. Guess it's already sorted. That's fine. -3. No, it's not already sorted. Guess I can try to visualize this. -3 to 3 is this one. So from here to here, it's going to be -1 slope, -1 intercept. And then from here to here, I think, is the next pair. So slope is 0.2, 1/5. Intercept is 2.6. Here to here, slope is actually, is it here to here or is it something else? -2 to 2, 2, -3, 2, +3, 3, 0. Okay, let's keep here. So that minus slope -1/3. Intercept 1. And then 3, 2 is here to here. Slope is 0, intercept 2. Okay. And then it's going to do these two. Slope is infinity, x-intercept is 2. Here to here. Slope is 3. Intercept is -9. Okay, yeah, it's working as I intended. Okay. Cool. Well, I guess the main complication is counting the somehow working with the duplicates. Because I guess this isn't terrible to deal with this formatting for keeping sides. So for every slopes intercept that's unique, I need to keep track of the count of it, which is the number of sides that can be formed with that on that line. The number of sides that can be formed on that line. Then for every side, I need to also keep track of the actual points that are involved. If only there's a guarantee that there is no parallelograms that could be generated with these points. There are two distinct ways to build 4 points. I wonder if I should just ignore that edge case and just work with the general case first and then come back to it. I guess that's a little incremental solving of this issue. Don't feel great because I think it's the most difficult part is not done counting. Okay, but anyways, let's go ahead. It's also interesting that they didn't use the mod here. Or maybe 2.5 billion is within. Yeah, I guess 2.5 billion is within the bounds of the x of the number of things that can be generated here, and within bounds of it's going to be stored in a normal integer. Okay, so anyways, how to do this? For every slope intercepts, count the number of times it occurs. So slope intercept, how many times it occurs, and then do a mapping of the slope to intercept. Slope intercept, slope maps to intercept, slope intercept maps to count. Yeah, okay. Slope map. Let's do this via dictionary of lists. Maybe a default dictionary of lists. Here the key is going to be the slope. The value is the list of intercepts. So here, if this is line, then it would be slope map should map infinity. Actually, I don't even know if I can use the key of infinity. I probably can't. Append this intercept. And then here, this would mean that the slope map for this slope appends this y-intercept. Maybe it should be a set because the y-intercept can be the same. Yeah, maybe it should be a set. In which case, if you add and then I'll do the line count, the side count. Is it the line count or the side count? How many lines that are drawn? How many lines that are drawn that are the same slope? I guess I can call it the line count. So default dictionary of int, where the key is the slope intercept, and the value is count of lines with that slope intercept. So line count for this tuple is going to be incremented by 1. Infinity, now this is slope intercept. I probably can get rid of lines here. Well, it doesn't hurt for debugging purposes. Okay, so now I go through every slope and slope map, see if it has more than one thing in the set, in which case there's multiple lines that have the same slope that are unique in their y-intercept. So I guess I can say for every slope in the slope map, if the length of the set of y-intercepts for the slope is, let's say, equal to 1, and that means that all the pairs of points that have this, that create a slope of this, all are collinear on the same line, so therefore they can't form any non-quad or even trapezoid or even quad also. Let's give it all pairs of points generate a collinear collinear sides. Not possible. Otherwise, it's going to be. Otherwise, I need to look at the counts. Determine combinations. So let's go ahead and say answer equals 0 here. And then I'll start with the count of 0 here. Eventually I'll say answer plus equals to count. And then here it's going to be actually I think I need total. So for every I think this should refer to trapezoid. And I think I need a separate one for the count of the things of this size. So maybe this is the S count, the side count. In every side count in the line count, or I guess every line. No. I guess there should be line counts because each of these is a count. Yes, yeah, okay. Line counts. So for every count in line counts for this particular slope. No, this is wrong. For every y-intercept in the set, so for every intercept, how to abbreviate this? I guess it's not always x-intercept or y-intercept, it's just an intercept. Enter. In the set from the slope map for the slope. So get the line count from line count for the slope and intercept. And then that pairs with everything in the total. So the number of trapezoids formed is going to equal, I guess this should not be 0 here. The number of trapezoid formed will be equal to the count from this thing, from the lines that are here, times the previous total. No, I do need traps. So that's the number of trapezoids. So it's incremented by this. And then total incremented by the current count. Yeah. It's okay for non for the base case. Yeah. Let me think. So what was yesterday's deal? Yesterday I dealt with, you're given the, what was yesterday's deal? Because I don't recall using this way of counting yesterday. There was something slightly different. Where's my code? So I leveraged the fact that it was dealing with horizontal only. So therefore I kind of skipped over calculating slopes. Interesting. So when I did that, I had to reverse engineer the number of sides that were based on that pairing of y coordinate to count of x coordinates. Here I'm actually going through every single pair of points and getting the slopes involved. So therefore each thing here is actually an actual side. So I didn't have to reverse engineer the number of sides involved, which is equivalent to the count here. Okay, anyways. Okay, so it works on the kind of example cases, which are the kind of simple it's ignoring the huge elephant in the room, the parallelogram sized elephant, or the elephant sized parallelogram. Okay, I already considered vertical slopes. This is using infinity as the slope and x-intercept as the differentiator. only double counted because it's not triple counted, huh? It'd have to be some sort of hard problem that is dealing with convex or polygons of n with n sides, like n equals 6 or n equals 8, and checking to see whether or not those have multiple parallel sides that are being double counted in order for this to not be double counted. Answer could be so big. So if I register the number of that are involved. That'd be so many registrations. But registered points involved. So this one goes here, here. Well, these are the same points. Let's see. Should add some spacer between these two to highlight the fact that it's not some sort of one extended vertical line. 5 points. 1, 2, 3, 1, 2, 3, 4. So it's going to recognize that this thing, whatever slope this is, has 2 y-intercepts. And then this one pairs with this one, so it's 1 times 1. Could be even trickier if the points, they're like, if it was multiple things on the same line, like something like 0, 1, 1, 2, 1, 3, so like 3 adjacent, kind of one length thing here, and then 3 adjacent one thing above it, and then 3 adjacent one things on the side, 3 adjacent one things on the side, but just a bunch of lines that would form squares. And trapezoids and rectangles all double count each other. That's a mess. Let me go ahead and just add that to a test case to make sure that the messiest thing that I can think of right now that's simple to visualize is still going to work in the eventual solution. So like 0, 1 as 1, 2, Man, I'm typing this pretty slow. How to make this type faster? Maybe if I do 0, 1, comma, I guess I can just make it simply 1, 2, I guess 8, 4, 2 by 2, 4, 5, 6, 7, 8. Make 0, 1, 1, 2. I'll say this is 0, 3, 1, 3. And then, what am I doing? Must be, well, I guess that's fine. 0, 0, 1, 1, oh, those are actually vertical. 0, 1, 1, 2, 0, 3, yeah, I screwed up. 0, 1, I think I need 3 points in order to make 2 things. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so horizontal or vertical. 0 to 1. Oh, actually, shit, this needs to be 0, 0. 0 to 0 to 1, 0. 1, 0 to 2, 0. So that's the bottom. And then just the top. X coordinate is 0, Y coordinates, let's say 3, sure. 1, 3, and 2, 3. And then the sides, I'll go up 0, 0 to 0, 2, 0, 2, 2. Oh, there always is 0, 3. Okay, so I guess maybe 0, 1 to 0, 1, and then 0, 2. And then on the other side, it'd be 2, 1 to 2, 2. Okay. Yeah, so I double counted for sure. 72, is that what I expected? 72 was actually a bit more than I expected, I think. Maybe I just need something simpler than this. It's probably pretty complicated. Oh yeah, no, this is just too complicated. Well, I guess I'll keep it and then I'll just move on. 0, 0. Man, I thought this would be pretty small, to be honest. 1, 2, 3, 4, 5, 6, 7, 8. 8 points is necessary. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. Let's see, visualize this points here. Give me a table. 0, 0. Points. 0. I guess, yeah, 1, 0. So I want this to be connected. it's connected. Lines. 2, 0, 2, 1, 2, 2, 1, 2, 0, 2, 0. Okay. Holy bejeebus. Let's go ahead and 0, 0. Okay. I can probably do this. 0, 0, 1, 0, 2, 0. Just need to think about this in terms of just going around the square. And it's 2, 1, 2, 2, 1, 2, 0, 2, 0, 1. That's nice. So this is 30. So 30. How do I get 30 from here? So 1, 2. Maybe I just need to simplify this. This is 30. 1, 2. Maybe I just need to remove like the 1, 0. That should at least make it a little simpler. Yeah. 2, 1, 0. Home. Oh, still 30. So the 1, 0 didn't actually add any more stuff. Interesting. So there's 3 things here. There's 3 things there. How do you even get 30 from this? 1 times 3. I need to simplify another side. I think I'm going to remove the 2, 1. No, see if I can't work with that mathematically. Or if this is still 30, this should be less than 30. Oh, whoops, I'm modifying the wrong thing. Shit. So removing these 1, 0 and the 2, 1. Okay, it has to be. Okay, so it's fucking 6, okay. 6, and I counted 7 using my original thing here, so 6. So the whole square is a trapezoid. That's 1. And then if I have the bottom but only a 1 length on the top, it's 2, 3. If I had this side, only a 1 length on this side, then it's say 4, 5. there's one other one. Oh, interesting. It's going to be this parallel one from the diagonal. That's 6. So yeah, 1 with this bottom and 1 length tops is there's 2 of them with this side and 1 length over here. It's 2 of them, so that's 4. There's the diagonals. That's 5, and then there's the whole square. That's 6. And then my deal was 7 because I'm double counting the whole square. Double counting the whole square. So from this horizontal, it's like doing 1 here and 3 here. It gets 3 from this horizontal, this vertical. So this vertical is doing 1 here times 3 here. So that's 3. So, and then it does the diagonals, 1 times 1. So how to not do that? I track the I somehow track the points that are involved. Does that help? Track the points that are involved. I could track just the leftmost points. If I track the leftmost points, does that uniquely identify things? So how can I tell the square from double counting? So when I do this thing, I'm going to do 0 to 2 and 2 to this. If I kept point indices, doesn't make sense. Kept the point indices. So for every slope line, no, I just can't. No, I can't just keep track of the 2 leftmost because it could be the rightmost that need to be looked at in order to see if it's parallel to leftmost. Is that correct? So every trapezoid leftmost. So for each point, yeah, maybe. If I kept track of this and this, so it would be identical for this and this, leftmost points. And then if those points are the leftmost points, what if I this is not going to work. Because the leftmost points here are vertical. But if this was slightly, if there was another point like here, then I could be forming a trapezoid that's vertical where those are the leftmost points. But it's not necessarily a square versus this one. So like if this point here was moved to, so 2, 2 became 2, 3. So in theory, I have a trapezoid here, horizontal trapezoid that has these two as leftmost points, and also a vertical trapezoid has these two as leftmost points, but they're not over enough to count each other. They're not double count each other. Oh. I'm gonna give myself maybe another 10 more minutes and call it a wrap here. Some hards are too hard. Oh, how to deal. I wonder. Parallelograms. How do you determine parallelograms? What was the properties again? Maybe I'm missing something. I really don't need to watch a minute video to read a few sentences. Shape has two pairs of opposite sides. Opposite sides are congruent. Opposite sides are congruent. Opposite angles are congruent. diagonals bisect each other. One pair sides is parallel and congruent. Oh. Parallel and congruent. Yeah. Okay. Interesting. Parallel sides is parallel and congruent. So I need to keep track of both the slope, y-intercept or x-intercept, and length of it. Okay. Is that too much to keep track of? Probably not, actually. So the count. So the mapping needs to be slope, y-intercept to the slope, y-intercept to the list of lengths for that. The list of lengths. Because I can't just have a count. I need to actually know what the side lengths are for that. Yeah. And then I need to list of lengths. I could also go map from slope intercept to the side lengths, and then for each side length to count the things that got side length. That's a disgusting amount of mapping. That might be necessary. I think if I can somehow avoid using a bunch of these dictionaries. So slope, y-intercept to maybe the set of distances. The set of distances, and then the dictionary from slope, y-intercept, and set of distances to the actual count. Fuck. Okay. So I need to know the distance between these 2 points. Okay. I'll just keep track of the square of the distance, since that's proportional to the distance and also unique to it. So it's just me square root of x squared plus y squared, square root of the square of the square root of difference of x squared plus distance of y squared, right? So x2 minus x1 times x2 minus x1 plus y2 minus y1 times y2 minus y1. I guess I could decompose this to be like delta x, delta y. Slope map, line counts. I guess I could segments, distance map. What do I call this? I think I call this maybe segment map, like line segment. Segment map is the default dictionary to a set where the key is the slope and the intercept, and the value equals set of distance or set of length of line segments formed from those points, those pairs. Yeah. So slope map had segment map where I'm dealing with the slope and this intercept, which is x1, adds this distance squared and then I have the last thing, which is the count, segment count, which is also going to be default dictionary int, where the key is the slope, intercept, and the length, the distance, and the value equals the count of line segments, that slope, intercept, and length. Oh, I need to have done it here. Oh, whatever. So this should be seg count for slope, intercept, distance, plus equals 1. Slope map, segment map. For the slope and this intercept, add this distance, and for this segment count, for the slope, intercept, distance, add this segment. Okay, and then I can do something like double counted. And then I just need to determine when it's double counting. So the overall thing is the same. Well, Probably want to just redo the calculation based on segment mapping, segment count, and maybe get rid of the slope, get rid of the usage of line counts. Okay, so not using line counts, I can say that what can I say here? For mapping slope and maybe I just keep it rather than try to recalculate it using the other thing, and try to just use the other thing to calculate the double counted parallelograms. So how would I just calculate the double counting stuff? So if we're dealing with something with a particular line count, slope, y-intercept, slope, y-intercept, and distance is the same. So we're going with the slope. We're going with the same distance but different y-intercepts. Same distance but different y-intercepts. So for every intercept, same distance. So I guess I need to know the previous counts of I do need to redo this calculation. Okay. So I think I need to know for every prior slope. So I'm dealing with everything with the same slope, and everything with the same slope that has the same distance between the points is going to be double counted. Assuming it's not on the same y-intercept, because otherwise if it's on the same y-intercept, it's not iterating at all. So I think I go with prior, so like it's going to be something like a distance count. And this should be a default dictionary events. Let's go with trapezoids that are being counted. And I guess I still do need total. Yeah. So for every y-intercept. So, yeah, every intercept in the slope map. For the slope. Iterate over every distance of this y-intercept for every distance squared in the segment map for this combination of slope and intercept. And then maybe I do need a separate thing called current. Yeah, so this thing should eventually do something like distance count of distance squared is increased by the segment count for this particular slope, intercept, and distance squared. So that needs to be done. I think I do need to say something like current plus equals the same deal. So it's the current for this particular distance, for this particular slope intercept. And then the main thing is going to be the number of trapezoids should increase by the number of ways to get. I just need to know the current count related to this. So count is going to be segment count, the slope, intercept, and distance. And then eventually current increments by the count, and the distance count for this distance squared is incremented by the count. And after this, it should be something like total plus equals the current. Because I want to basically on this particular line, or this line all share the same slope. On a particular line that share the same slope and y-intercept, there might be multiple segments that have different lengths. And for every segment that has the same length, I'm going to somehow deal with it. So the double count should be incremented here before I do this. So double counted is increased by the number of previous things that have this distance. So if this thing has one distance, the number of prior instances where I saw something that is one distance within this slope. Yeah. Because that's going to be also the number of things that, yeah. Count, segment count for this. Need to increase the trapezoids. So for this, the combination needs to increase by the number of ways this thing forms with the total, I think. Yeah. Current is the stuff for the same slope intercept. And then total increases by the current. Yeah, I can't do this thing. I can't update the total immediately because I could be still dealing with the same thing on the same line. It has to be after dealing with things on the same line to increase the total. Otherwise, it's going to do this trapezoid calculation too early or get too much. Then I guess is after this that I increment the trapezoid. Okay, I think here is old code. And this stuff is out of date. Okay, well, there goes nothing. Slope is not associated. On line 20. Did I delete the slope? Did I delete the slope calculation? That's pretty bad. No, I didn't delete it here. I guess the slope here should just be infinity. Oops. I wonder if I can actually combine this code, right? This is actually identical code, but just different. Yeah, I can refactor this. So I think I can say here that the slope is equal to infinity, and the intercept I'm dealing with is x1, else I do these two. And then in general, I will do in lines append the slope comma intercept. Line counts is outdated, but I'll update it for sure, just to make sure everything's work in general. And then I'll remove it once it hopefully works. And then slope map for this slope adds this intercept. And then segment count, segment map for this slope and intercept combination. I need to actually calculate the distance. No, the distance already calculated there. And the distance squared. And the segment count for the slope, intercept, and distance squared combination increments. Okay. Lines or line. To be or not to be plural? That is the question. This should be lines. Intercept misspelled or just not declared? Alright, this is y-intercept. Ah, mother shuckers. Still. Oh. Oh boy. Answer minus the double counted, minus half the double counted. Oh boy. Well, solve the easier of the two. Oh my lord, I don't even want to figure this out. What is this? What is this? Okay. So still counting too much. Question is, do I want to try to figure out this particular input that I created on accident, or something simpler that I can formulate that probably has the same issue? Can I 1, 2, 3, 4, 5, 6. I mean, I guess it's 8 points. There's 25 deals here, 29 deals. Eeks! My brain is mush. 0, 0, 1, 2, 3, 4, 5, 6. How'd this get to 7? Oh boy. 1, no, there's an extra 0, 0. Okay. Let's just do this since I have it up. I mean, I assume this is going to be fine. Oh. But it could be wrong. Okay. So let's go ahead and make this 2, 2, and maybe add a 1, 0. Please be wrong. Okay. Sure. One, 0, and then this is 2, 2. Okay. So still not double counting enough. So let's go ahead and see how much it double counts. I assume it double counted maybe 1 or 2. 2. I mean, it has to double count an even number, so 2. It's not printing out the double count. No, it prints out 8. So that means it detected 8 instances of parallel lines that were yeah, that's not right. This should be distance count of distance previous times this current count. Okay, well, slightly better, but still not correct. Distance count for this distance squared. This distance squared. Total increments, but every intercept. Okay, let's think of this. So I guess maybe I should print out things. Guess maybe I should print out things. Okay, so print out the. I guess I can print it all out. Put it all out. Print out the lines. Print out the slope map. Print the segment map. Print the segment count. Okay, it's gonna be messy. Diving deep. So, what do we have here? So for each possible pair, this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. What is this printing actually? printing out the lines, where the lines are defined by the slope and intercept. Is this a set? This is just every single pair. So there could be duplicates. First two are duplicates. So here it's going to be 1, 2, 3, 4, 5, 6, 7. So there should be 7 times 6 divided by 2. So there should be 21 pairs. And by reformatting this, I'm going to approximate 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21 pairs there. Okay. So all that's fine. And then the next thing I print out was the slope map. So this should map the slope to the list of to the set of intercepts that can be obtained with that slope. So this would be this thing. So for infinity, there are, so that's going to be vertical. So you can have a vertical line through 0, 1, and 2 as the x-intercepts. 0, 1, 2, okay, that's fine. And the slope is 0, you can have 0 and 2 as the y-intercept. 0, 2, sure. The slope of 2, you can have 0 and negative 2. Slope of 2. So yeah, it'd be these steep vertical, steep diagonals. Slope of 1 can have 0 and 1 as the y-intercept. That'll be the 45-degree diagonals. Okay. Slope of negative 1, you can have 1 and 2. So that'll be these downwards diagonals. Slope negative 1/2, you can have 1 as the y-intercept, just 1. So I think that's correct. Slope positive 1/2 is just 1, that's fine. Slope negative 2, y-intercept is 2 or 4. I think I recognize that. It's these two. Okay, those are the only things that you can form. And then the next set, this should be the segment map, which maps for each slope and y-intercept the set of segment lengths. The set of segment lengths. So, oh boy, infinity 0. Okay, so vertical line 0 intercept, 0 x-intercept. The segment lengths are 1 and 4. Okay, this is, oh yeah, this is the distance squared. So I think that's right. So it's either going to be 1 length, which are these ones, and 4 length squared, which is that. Okay. 0, 0. Slope is 0, y-intercept is 0, length 1 or 4. Yeah, those are the bottom ones. Slope of 2, y-intercept is 0, just 5. 2, y-intercept is 0. Okay, so I think these are fine. Alright, finally it's going to be combination of slope, intercept, and distance squared, and the number of things, number of line segments. So 2, yeah, that's fine. Things that are 1 length, there's 2 of them. 4 length, 4 distance squared, there's 1 of them. So that's just like these 2 are 1 length, and this one is distance squared is 4 length. Okay, so I think this is all fine. I understand it. It looks correct in terms of its presentation. So now the calculation of it. Alright, I'm going to stare at this code and see if I can't recognize the issue with the calculation. So for every intercept, for every slope, okay, every slope, if there's only 1 intercept for that slope, then ignore it. Yeah, it's fine still. So here, this it reaches it if there's more than 1 intercept. So that means there's going to be at least something formed trapezoidally. And so I need to keep track of all the distances seen. All the distances seen. All the trapezoids that are formed. The current number of line segments for this line. And the current total of all previous line segments for the slope. And then for every intercept, and then for every distance at that intercept, count. The trapezoids formed would be the count times the prior total. If it's the first thing, the prior total is just 0. Otherwise, it's going to be whatever it is at the previous intercept, including the previous intercept. Then the current is incremented by the count, so the current is just the number of line segments on this particular slope intercept. Double counted is the current count times however many times there have been this distances that have been this distance. And then I increment the current distance. Why doesn't this work? Distance count. Distance count for this distance squared is incremented by the count. I mean, it's not possible for it to be like triple counted, I don't think. There's 2 things that have a distance of 1 here, and there have been 5 prior things with a distance of 1 elsewhere. And every one of those pairings would be a parallelogram. So the double count would include those things. Go ahead and say that this is the doubled. And then print out checking this out. Print them out that's doubled. Maybe print out the distance involved and the guess the slope intercept. I'm going to be able to parse this. Okay, so so there's one double counting where the slope is 4, or the distance is 4, the slope is infinity, the intercept is 1. I think I understand that. I think that would be this one with this one, going from 1, 0 to 1, 2. That slope of infinity, distance squared is 4, compared to origin to 2, 0. Slope of infinity. So, yeah. So even though that forms a trapezoid, it's also going to form a parallelogram. Okay. There should be another one that is also infinity 4. So 2 double counting for 4 distance squared infinity slope at x-intercept 2. So then this one right here forms a trapezoid, this one and this one. Also parallelograms with both. So it's double counting 2 things there. Yeah, okay, sure. So then it's this one, 4 double counting 1 distance from 0 to, no, slope is 0, intercept is 2, slope is 0, intercept 2, 4. Okay. I think that's going to be this thing compared to this thing. Everything that is 1. Yeah, 1. So 1 here, 1 to 1 here, 1 to 1 here, 1 to 1 here. That's fine, that's 4 double countings. 4 parallelograms. And then one double counting distance is 4, distance squared is 4, so distance is 2. Slope is 0, y-intercept is 2. So I think it's this whole line with this whole line. Okay. Seems fine. 1, 5. Distance squared is 5. Slope is 2. So these two. That's fine. And then -2 slope, so these two. Oh boy. So the issue is I have double counted everything that I have considered is a possible double counting, but I must not be considering everything that is possibly bad. Oh boy, oh boy. Well, I wouldn't recommend this, but I'm just going to go ahead and see if I can't leverage the fact that Leetcode provides some test cases anyways. See if they have a simpler test case that would also give me insight into what the hell's going on. I think I cleared up all this code concept stuff. Okay, this should print out this stuff. Or this should. Wow, took it 222 test cases to get to something bad. But yes, as I was hoping, this is a simple test case that is easy enough to parse. I wonder if I can just relabel some of these numbers. Kind of big, kind of whack numbers. I assume I can just remap these numbers into something that's equivalent. Well, where's my test case? I guess maybe I should just copy this. Okay, so I'll remap this into smaller numbers. -94, you are now -1. -57, you are now -2. 99, you are now 1. -78, you are -3. 83, you are positive. 74, you are 4. I don't think I saw a -27 before. Okay, you are, let's say, -5. Should be both equivalently same output with different wrong answers, or same degree of wrongness. Okay, so then I guess I'll just make this into a set of points. Guess I'll just hide this. Undo. How do I undo that? Right, whatever. And I make these into points somehow. -1, -2, 1, 1, -3, 2, -3, 4, 1, 5, -5, -2. Okay, so this is gonna be six stuff. 1, 2, 3, 4, 6. Let's go ahead and maybe connect these. Is it possible to connect the dots? Points, lines. I don't know if that was particularly helpful. -1, -2, 1, 1. Maybe if I reordered this and said the 1, 1 was later. Well, 1, -3, -1, -2, 1, 1. 1, 1. Let's try this again. Let's go 1, 1. -5, -2. Then -1, -2. 1, -3. 3, -3. And then last but not least, 4, 1. Alright, just close up the loop. Back to 1, 1. Okay. So, how many trapezoids? So this should be... no trapezoids out here. So I said 4, but it should be 3. Okay, yeah, there's a parallelogram there. So that's 1, 2, with this one right there. There's the third one. And these? No way. There's 3. There's 3 somewhere here. Oh, I see. There's this one over here. Actually, is this a parallelogram? -1 to -5 is 4. 1 to 3 is just 3. Or 1 to 4 is 3. These aren't, this is, if these two dots are connected, then it's not really, that's not a parallelogram. Slope is 0. 3 lines with 3 different lengths. Alright, let's go ahead and just look at the code. Okay. And this part's a little more extra here. Lines with slope, intercept. Actually, I think I probably don't need to see this. Slope map with, this should be slope to set of intercepts. Segment map with slope intercept to set of distance squared, and then segment count with map of slope intercept distance squared to count of line segments. Get that information. Alright, so do this here. So slope is 0, intercepts are going to be 1, -3, -2. Yeah, so positive 1, -3, -2. Slope of -1/6 is going to be -2.3. Slope of 1/2 is positive 1/2. Slope of -1/6 is, I think, here to here. -2.3. Sure. Slope of 1/2 is here to here. And that's negative slope positive 1/2 is positive 0.5. Which 2 points is it going through? Slope of positive 1/2. Slope of positive 1/2. Can't possibly be these two. Up 1/2. Okay, never mind. I'm a dum-dum. Okay, so that's all fine. Okay, I think I just need to start going through the actual printout of when this thing actually detects stuff. Here that time. Huh. It should have detected one. Huh. Oh my god. So is it hallucinating, or I mean, is it, did I somehow add an extra that should not have been counted? Alright then, let's go ahead and see where it actually detects things. So count. So count times total is greater than 0. Print counted. Let's say how much it counts and the relevant information. Counted 1 and 3. 1 for when dealing with a distance squared of 4, slope of 0, y-intercept of -3. Slope of what? Slope of 1. Slope of 1, distance is 2. Slope of 1. Coming out the distance, no. Count total, distance squared, the slope is the third thing. Slope is 0. Okay, distance is 2, y-intercept is -3. So we're doing this one right here. How odd. Ew. Why is it only increasing by 1? Actually, that's right. Yeah, that's right. So this is like comparing this thing to, I think, this thing. I think that's what it's doing. It's going from slope -3 and then it has -2. So it already did it already did the y-intercept of +1. So it's comparing this one to this one. And it counts that once. And somehow it's going from this one to this one, and it's getting 3 rather than 2. The total is not increasing correctly. Total is, oh my god. Oh my god. Oh my. Well, that was truly, truly sad. Oh my god. So bad when I have logic somewhere in my head but just can't compute it or produce it in code. Alright. Just 19 test cases. Oh my god. This case is so huge. I'm not going to be able to determine this. Oh my god, it's like too off. Oh. Okay. Okay. Can I logic my way to to where the error is? Because there is an error. Just because it's close doesn't mean it's correct. Definitely doesn't mean it's correct. Okay. So number of trapezoids. It's too off. How could it possibly be that correct, but that slightly incorrect? Like, is there an edge case this is missing? Is it... Ah. Vertical lines handling. It's 5 freaking... Let me go ahead and just print out this thing here. -209, -385. 110. Okay. I wouldn't recommend doing this, but I'm going to try fish for a fish for another test case that goes wrong on and see if I can't debug that rather than this one. So if my length of points is magical 110, actually maybe I should just do if points at 0 is 0, is 209 and points at 1 is -385. Return the correct answer of 11025. Okay, I just want to find another test case that I'm doing wrong. Let's Did I mistype this? Isn't this the same test case? Oh, I sorted it. Whoopsie. I don't want to sort this before doing this hack. Okay, how big is this? Still too big. Off by 2, it looks like. Off by 2. Still, so it means I'm double counting something that I'm not catching. Double counting something that I'm not catching. So for every slope in P1 to P1, okay, all points are distinct. Wonder if I actually need to sort the points. Don't think so, right? It's not helping me at all. Oh, did sorting points actually hurt me somehow? No, actually it's just because I have this hack. Funny. Funny. Okay. Well, this one's off by 4 actually, so it's not necessarily off by 2. Okay. But regardless. So every indice for the first point and every indice for the second point, not the same indice. Find the distance squared. Check for verticality. Do that exception. Otherwise, calculate the slope and the y-intercept. And then form the line. I guess I don't actually use lines, right? Yeah, I can remove that. In addition to the line counts, I don't think I ever use that anymore. Checking to make sure that nothing horrible happened within that. Okay, slope map. So map every slope to a set of intercepts. Segment map. Add the segment defined by the slope, intercept, and distance squared. Add that distance squared to the set of things defined by the slope and intercept, basically the line. And then the segment count every line and distance segment. Okay, I think those are all fine-ish. I think I can probably delete this now. Pretty safe in my assurance that I don't need it anymore. Alright, double counted. Slope and slope map. If everything is only on one line, then ignore. That cannot possibly be contributing to counting too much. Distance count. Every trapezoid formed currently. So this is the count of the trapezoids. Trapezoids formed with the slope. With current slope. Total is going to be count of prior line segments with the slope. And then for every intercept, which defines the line, current here is going to be, this is the count of line segments on this particular line. defined by the slope and intercept. And you have your distance squared. And then this is the number of line segments. Number of trapezoids should be the number of things for this line segment multiplied by all the other line segments on the prior lines. Seems right. Current line increases by the number of line segments. Things that are double counted are the current line segment multiplied by the prior things that have this distance, which resets each time. Yep. Increase double counted. Double counted starts at 0. Distance count. This distance squared is increased by the current count. I think that's fine. And then after you finish this distance, then increase the total by all the line segments that you found in this line. Man, where did I go astray? I mean, it could be counting too much. It couldn't be not counting enough. Or it could be like somehow yeah, I wish the thing it failed on was a little simpler for me to parse. This is helpful only in the sense that it tells me there's an issue. It's not helpful in the sense of getting me to know what the issue is on an understandable level. Yeah. Almost nice. Almost nice. I wonder. I wonder indeed. I mean, I think I can probably delete this here. How to deal with this? The question I posed myself so long ago. Still relevant. And I think double counted divided by 2. If it's, is it possible I'm not considering everything that's parallelogram using this method? Where would it fail? So the distance. Distance squared. y2 minus y1, x2 minus x1. Like it's possible for the intercepts to somehow round differently, is it? Is it possible for the intercepts to somehow, on accident, form different based on the division? Okay. Let's ask Google AI. Gemini. When dealing with Python decimal, I guess, is this real? Is this a double? Decimal values. Is it possible to have two fractions, two equivalent fractions be converted to decimal values that are different? Because that does define my slopes. Interesting. So I think it might be a precision issue. I guess I was just hoping that it was not an issue, but it definitely seems like I probably screwed this up in this area. Okay, we can call division fraction type, which maintains fraction number precision, then convert to decimal. Division using the fraction type. Yeah, interesting. So the slope needs to be stored as a fraction. Is fraction the most efficient I can spell it, way to store slopes? was the same imprecision with dividing, restoring a division in decimal, an issue with float. Okay, yeah. Python decimal type and use pasting that when you initialize. Only if, oh, okay. So I wanted to use decimal, but it was automatically using float. I guess I was confusing. I was automatically using float and decimal interchangeably, or in my head. Slower than float, faster than fraction. So this is only bad if it's if one or both fractions are converted to standard Python float before being used to create decimals. One or both fractions converted. Why is used to avoid typical issues with float-based two numbers. So I need to have decimal stored. This convert both things to decimal. Find the dividend and divisor as decimal objects. Always initialize decimals from strings to avoid imprecision. Oh my lord! That is so gnarly. But I'm not above it, I guess. Okay. Convert. Convert. to integers and strings. It's the easiest way to get the decimal that more memory efficient than keeping the fractions for later usage. Okay. Functions can be compared to okay. So I need to do fractions, I guess, rather than convert them to decimal or some other roundabout way. So the slope here is just not right. I guess I could store none slope. I wonder if that works. Google Gemini. Can none be used as a key to a Python dictionary? I've never done that, I don't think. Okay. Slope is none. Your slope is going to be the fraction y2 minus y1 comma x2 x1. Do I need to import fractions? Assume it's probably imported from fractions import fraction. Okay, maybe not. So that probably is the only thing that really is an issue. Okay. Oh my god. Is it too slow? Please, not. Please. Are you fudging me? Oh. 546. 5 test cases, although this one's probably a pretty big test case. We failed. Okay, what is the length of this shit? This is one of those things where there's 5 test cases I could definitely hack, result hack to finish it off. Just figure out what the exact kind of inputs are that I'm not getting correct. Actually, I'm not sure. Maybe Leetcode does have some hidden test cases. That makes I don't know if Leetcode does that. I think well, it definitely does it for tournaments, but well, we're selling 468, which is an upper end, but not certainly not that big. Okay. It's just not doing it fast enough. Wonder if I can actually just speed this. Wonder if this works on the test case. How slow is it? Oh fuck me. Did not mean to actually submit. Just wanted to see if this test case actually ran and completed without going over time for my current solution. Wow. Quite the start of December. Okay, so it does run it. It takes more than a second. It takes probably damn near 1.5 seconds to do it. It's just not fast enough. Just not fast enough. How much slower this thing is compared to actually using non-fractions here. I wish I had not actually changed it. So before, when I used decimals, it just did this, right? And it's like y2 minus y1 divided by x2 minus x1. So it ran it in much faster time. 278 obviously got wrong, but fractions really did slow it down. Slow it down by a factor of like 5. 3 seconds or 300 milliseconds, so 800 something. 300 milliseconds, so 1.8. Okay, so maybe I just need to find a different way of handling these fractions. Oops, oops, oops. Let's now I create the slope. Slope fraction y2 minus y1 over x2 minus x1. I mean, can I do my own lowest? Is it faster? Or can it be faster to determine the lowest, the reduced integer numerator and denominator, and store those for a fraction rather than dealing with a reduced fraction with a fraction object. Convenience and safety. Remember? Okay, just give me the code to get the reduced. Can you please give me code using math.gcd to get the lowest reduced numerator and denominator from to Python integer. Common divisor GCD absolute numerator denominator reduced numerator and denominator by that thing. Okay dokie, so I guess maybe slope needs to be a tuple reduced. So I'll say this is 1, 0. Okay, so this is, let's say factor is, sorry, common is that, yeah, I guess just DCD of abs. Interesting. I wonder if I don't think I care. So I'm gonna make it positive by just translating by 1,000 and call it a day rather than calling it a function. So y2 minus y1. Actually, translating is not translating is not actually going to make it positive. That's just stupid. Okay. Absolute value of y2 minus y1. Absolute value of x2 minus x1. And then the numerator is going to be y2 minus y1 divided by the common. Denominator is going to be x2 minus x1 divided by common. And then the slope would be tuple that is the numerator and denominator. Slope is where is now associated to a value. Oops. Equals int and intercept. I see. Yeah, that's probably going to require a little more work. Okay, so this should be the slope, the numerator. Actually, I already have the values here. Numerator times x1 divided by denominator. Oh boy, is this gonna work? Well, I already have the reduced slope. Oh, shucks, cahoots. So the slope should be itself should be correct. Mother Lord. So the only way I'm going to guarantee this is to think about the fraction itself, isn't it? Fraction itself. So I need to convert both things to be over denominator. So this thing needs to multiply denominator with denominator. So that it's all integer based. So it should be numerator minus x1. And multiply this y1 times denominator with denominator. Then I have a common denominator. And then I convert. Yeah, I think that's right. So I think I'll say here this is b equals y minus, let's say, n over d times x, which equals yd over d minus nx over d, which equals yd minus nx over d. Okay. And that just is all sorts of off. Oh my god. Did I do this wrong? Slope is numerator times denominator. Numerator. Must have done something wrong here. Gemini, what's going on, buddy? Standardize the sign. Ensure the denominator is always positive. Oh wait, I guess I missed this part. Divide both numerator and denominator by the GCD. Standardize the sign. Ensure the denominator is always positive. I see. Standardize the sign. Ensure the denominator is always positive. Yeah. So here it should be, if denominator is negative, then reverse them. If denominator is less, wait, what? Yeah. If the denominator is negative, then I'm going to say numerator times equals 1. Numerator and denominator equals numerator times -1, denominator times -1. Okay, I think that's what was missing. Okay. Ah. Well, I guess this works. With a little help from my Gemini friend. I don't think it's cheating to help get the help that I did. Certainly not as big a triumph, but sometimes you have the smaller triumphs rather than just the ultimate fails. I think I could probably just remove this variable. Alright. Okay. I think maybe that code is as clean as I am intending to make it. Okay, so summary here. I think I'm just going to delete this thing. Yeah, whatever. So I'll say here refer to the easier version of this problem, yesterday's challenge, to better understand logic if that hasn't been done. So here, what's the deal? Oh, I don't need input fractions anymore. So the key things would be key parts to above solution is to address how to track the different line segments that can be formed by any pair of points. And part B is how to not double count parallelograms as two distinct trapezoids, as both pair of opposite sides will be parallel. And really, this second part is what is the main issue. So how to describe what's happening here. Since above work revolves around handling the second issue, key understanding is that if two line segments are parallel and obviously not collinear, not on the same line, linear, is that spelled with, yeah, collinear, then they can form a trapezoid. If they are additionally the same length, they will form a parallelogram. So they will be double counted. If you do a straight count. So double counted trapezoids. So code needs to keep track of segments by slope of the segment, the intercept, to differentiate collinear and non-collinear segments. Collinear and non-collinear segments, and distance or length, distance/length a segment, distance between points. Okay. So I'm going to say in a very broad sense, you need to use maps, or I used maps and dictionaries to keep things organized. Used loops over the appropriate values to get counts for how many of each things we're dealing with, how many combinations and double countings are occurring. Importantly, I use reduced integer values for storing slopes rather than decimals or floats, since those can be imprecise or just too slow. And then the answer is reduced by half the double count. And that's pretty much it. So every pair of points, we calculate the distance between those points. I'd keep track of distance squared, since distance squared is just a better way of keeping track of things rather than taking the square root, doing decimals, and whereas distance squared is also kind of equivalently unique to certain distances. If it's vertical, then the slope is going to be stored as a tuple. Well, yeah, slope stores tuple, or whatever. Reduce tuple, I'll just say 1, 0. For a line that is a slope of 1, 0, the intercept there is going to be the x-intercept, which is to differentiate the lines. So it's going to be the x-coordinate of either point. And then if you have a non-vertical line, you need to find the greatest common denominator to reduce the fractions of the slope. Divide out that greatest common denominator. Ensure that the fraction is going to have a positive denominator, so that it's not like -1 over 2 is not different than positive 1 over -2. Store the slope as a tuple of the reduced numerator and denominator. Store the y-intercept to differentiate lines with that slope. And then have sets for all the intercepts from a given slope, all the distances for a given slope and intercept, so basically a line, all the line segments that could be on that line differentiated by their distance, by their length, and then a counter for every line segment on a particular line with a certain distance, with a certain length. Have a counter of the number of times that occurred. So like if the slope is 2 and there's a bunch of 1 unit line segments on that thing, there could be like 100 things on 2. And then you have your main for loop, nested for loop, goes through all your slopes. All your slopes will determine things that could be parallel, opposite sides of the trapezoid. But if there's only one line, if all the line segments that are of a particular slope is just one line, then therefore you can't form any trapezoids. Otherwise, it's going to be something. So we're going to keep track of the distances. We're going to keep track of the number of trapezoids currently formed based on the slope, the current total number of prior line segments with the slope, and then for every intercept, which is for every line, we're going to keep track of the current number of line segments on this line, and then for every distance, for every segment length, on this line. Get just to count from the dictionary. And then the trapezoids formed from this would be the line segments on this line multiplied by all the other line segments prior with the same slope. And this is the logic here. It's just very similar to the last challenge problem. And then increase the current number of line segments on this current line. This is because we're just dealing with the current line, like everything, all the line segments on the one line, we can't increase the total count immediately because otherwise we'll be making combinations for line segments that are collinear. So this is the current count. It's increased by the line segment count here. The double counted is the count of the current count times the prior line segments that we see of this distance, and then we increase the number of times we saw this distance by this line segment count. And then wrap that up correctly. Hopefully you don't put the wrong initialization in the wrong places like I did. Cost myself 3 minutes. And then increase the answer by the number of trapezoids formed from the slope. And then remove the double counting. Alright, time complexity, this can be O of n squared to iterate over the points array with a nested for loop and get the info for every pair of points. And then the calculation for the number of trapezoids will also iterate over kind of dictionaries and maps with the same complexity. Okay, it should be slightly faster, but it should be overall, in worst case, the same complexity. Space complexity, this can be O, I think it's O of n squared as well, as every possible combination is probably somehow kind of referenced in the dictionaries and maps used. Okay,